All right. So what's next? What are we going to tear apart now? So now you take the...
Now we're going to look at the inside of the transmission housing.
Okay.
So,
is there any maintenance inside of here?
There's no routine maintenance. There are some parts that occasionally will get repaired, usually if the failure in the transmission housing is...
That's where it gets expensive, right?
Right. The only reason I take the transmission housing or break it open is so that I can get in case there's heavily emulsified oil. You know, if it's really milky and, you know, it can get as thick as whipped cream.
Yeah.
In which case...
Then what do? You just flush oil through it? Or you just start
wipe it out really well and then...
Get as much as you can out and then...
I'll stand the machine vertical. There's one case where it's okay to run it upright. And then put a little bit of oil in the back end because there is a bearing. The front motor bearing is pressed into the back of the transmission housing, so it gets lubricated by the oil that's in the transmission housing. And then the oil seal is behind it. So, and that's the oil seal if there ever is oil leaking from the back end of...
Yeah, that's where we get some oil
If you
leaking.
get it there or back here, it's because the seal in the back of the transmission housing is not sealing properly. It can either be as a result of a defect in the shaft, like an imperfection. Most cases, especially if it's on a new unit, we're going to end up swapping it out. But because the transmission housing has to be replaced for that. It's easier to replace the whole housing than it is to take out the bearing and the seal and then press it back in. It's labor, you know, intensive.
Yeah, we've seen that quite a bit on the 1322s. That does happen. Not quite a bit, but you know, a much higher percentage than on the 1122s. I'm not sure why.
I'm not really sure why either. I mean, I haven't been able to nail down a root cause to that yet.
But that's not a simple fix.
No.
So if you got an oil drip, we gotta, and it usually only does it right out of the box.
Right. Now this is where things will pop out at you.
Okay, all right.
So there's 4 bolts to the faceplate holding it on the transmission housing. Each one of the plungers is returned to its neutral position with a spring that's pulling it back. The swash plate is pushing it forward.
Okay.
So what we're going to do is take, you know, I've broken loose all 4. We're going to take out 2 on an opposite corner, doesn't matter which, and then we're going to use the longer bolts from the valve housing to install into those 2 holes. We'll back out the remaining 2 bolts and then start to back these out so that you can release that pressure. Interesting. And once again, that's mostly because we're in a big hurry in the service department whenever we're fixing them. We're not in a big hurry, but...
Yeah, you want to get the job done.
Our customers, for some reason, don't like paying many hours of labor for what can be done quickly. If you're using an electric impact wrench, you definitely want to be light on the trigger. Now don't be fooled if you start to remove these bolts and it doesn't pop out instantly, because sometimes it will stick. Now we're doing this just to see the inside, but of course we will have some residual oil leak out. So of those 8 bolts, 6 are alike. Okay. You can get those 2 longer ones. So here we have the back of the faceplate.
Looks nice and clean.
So each one of our plungers, and sometimes we'll also check to make sure spring tension is is still good, though there's rarely, a reason for it not to be. It's of note to mention that the oil housing, the faceplate also has leakage return ports. So if any oil, and it helps to lubricate the seals. This all goes towards the reason why you're laying it down flat as opposed to standing it upright, because otherwise the oil seals aren't going to get the lubrication. So
because if all the oil's down there, it doesn't come up here.
Right, yeah. If it's sitting in here, it's not going to lubricate the oil seals. So 3 plungers. Now, on the front of the faceplate, if you remove this housing from the plungers, in some rare cases, this ring may also come with it. In which case, customers may mistaken the oil seals for part of the packings. These are a separate seal. They're sold individually. They have to be pressed in, square and straight. They're not as easy to replace as the water seals. That's not going to be a typical repair that is done by a DIY. However, if the machine is still worth repairing in the mind of the owner, I recommend replacing the entire faceplate, especially in cases where this may have gotten heavily oxidized. You can already see a little bit of it right there. Especially in high mineral content, a lot of DI water, salt water, those kind of things. If this starts to get completely oxidized, the new faceplate comes with all 3 oil seals already installed, as well as the O-ring that goes around that seals for the transmission housing. Now, one of the ways that cavitated pressure washers tell on themselves is that, so like we discussed, this is acting like a syringe. So when it's in here, the swash plate gives the positive motion. The spring is giving it the return motion. So if the valve housing is not filling up with enough fluid in the cylinder, enough so that it retains a vacuum, the plunger will not return all the way up against, it's not going to stay seated against the swash plate. In which case, you'll see hammering of the plunger on the thrush washer.
Because it'll bang off of it, basically.
Right.
Like knock almost.
And you've got the rotation taking place, and it'll happen with all 3. In which case, you'll get abnormal wear on the sleeves where the plunger is essentially getting torqued in a rotational position. So you'll see wear here, and wear here, like it's going around.
So that plate in there, that's what we call our wobble plate?
Yeah, the wobble plate is actually below this washer, which we'll take that off now.
Is there a retaining clip on that, or?
Nope. It just sets in place. So there's our thrust washer. And this is the process of cleaning out the oil.
So that thing kind of does this.
Yep.
And so as it circles around, this part kind of smacks or hits the valves.
The plungers.
Yeah, the plunger, okay.
So as it's rotating, there's a high point and a low point. So that's what a rotation looks like.
Interesting. And that's just driven by an electric motor.
Or a gas motor, and gas engine driven unit.
But isn't there a different way to create, not all pressure washers have wobbles, or they do?
No, not all do.
Isn't that a Kranzle type advantage?
Pump is a radial axial pump.
Okay,
so,
axial.
So it's got a rotational axis, rotates around one axis. Most box store pressure washers that are more, leaning towards commercial, those are crankshaft style pumps, and those are basically the inverse of an internal combustion engine. So where in an internal combustion engine, what's going on inside of the cylinders is what's driving the rotation of the motor shaft. The opposite is the case for the pressure washer pump. So the motor turns a crankshaft, and each one of the plungers has a connecting rod, and the connecting rod going in and out, going around is what
moves a
moves
plunger.
the plungers.
A lot of times a single plunger, right? On
No,
those.
they're also triplex pumps
Are they?
or triplex. So here we have the swash plate assembly consists of your thrust washer, the bearing, another washer.
These are uncommon repair items.
Yeah, not very common. However, this bearing set comes as a set.
That whole, again, the 2 washers and the bearing.
So that's you've got some bearing movement there to reduce friction, which is one of the reasons why this is more energy efficient than a crankshaft style pump, because of the means at which they reduce friction. And then there's your wobble plate.
So this pump here, 1122, has a slightly different wobble plate than the 1322.
Right.
Why did we do that?
Because the pitch of the wobble plate increases or decreases the amount of stroke in and out that the plunger makes inside of the valve housing.
Mm-hmm.
So if I'm not mistaken, I always get it mixed up. I believe the deeper the pitch, the higher the flow rate. But in most cases, the lower the pressure. So on these pumps, when you are driving with the same engine and you change the pitch of the wobble plate, you substitute pressure for flow or vice versa.
It's interesting because we rated the 1322 the same as the 1122. They have a slightly different pitch. But my measurements, I got like 1/10 of a gallon a minute more flow out of the 1322 than the 1122.
And how did you measure the flow rate?
With a bucket
Oh, okay.
and a stopwatch.
Okay.
And so I measured, I think, 1.9 and then 1.8 roughly is what we real world got out of with the stopwatch.
Yeah.
And a 4.0 nozzle on both. So these have a 4.2, so that would have, the stock orifice size is 4.2, so that would have made up some of the difference.
Right.
So this is rated at 1300 psi, 2.1 gallon per minute. This is rated at 1400 psi, 2.1 gallons per minute. But they have technically a different wobble. So if it's the same pump, I don't know why the Germans said that they needed a different wobble for that design. Because that pump is this pump, right? Everything's the same.
Everything else is the same. Your wobble pitch is the only thing that changes, that modifies the...
So they modify the wobble a little bit. So maybe the rating is just a little bit off.
Yeah, well, also I think that they were compensating for the nozzle size difference.
Yeah, that I was using.
Just to avoid overamping the motor.
Good call, yeah.
Because it's not hard to do.
Yep. So now, is this only the place where oil is? Is there oil down the shaft as well?
That's it.
So there's just oil in this little housing?
In that little tiny housing.
Huh. Okay.
It's cute, isn't it?
Yeah.
That's why this is my wife's pressure washer.
And then this, and then this here. So there's a windings. There's an electric motor inside behind.
Beyond that, yeah. I mean, if you look at this right here, there's your oil housings right there. Huh. So once the oil housing stops, the motor windings begin. You've got the stator, right here, and then your rotor inside. And
these are brushed?
No, brushless.
Okay. So no brushes will ever need to be replaced.
No.
It's funny, they don't market, that's like marketed as like a positive, like this big, amazing, brushed or brushless. It's stupid.
More common for smaller motors than it is once you get up to, and that's, you've probably noticed this, and some of your customers may not have noticed it because they're not seeing, haven't seen so many different models side by side.
Yeah.
But when you pick up the 1122, it's way heavier than all the other models.
Yeah, AR would be the only one that has comparable weight. They have giant heat sinks on the side that make it heavier.
Yeah, but and You know, it's not so much the aluminum, but it's the amount of copper and the steel of the windings that really give it and the steel of the rotor especially. When you pull one of those out, you don't want somebody to drop one in your lap.
Yeah, certainly not. Yeah, that's 47 pounds. This one's 80 plus. So this is what you're saying you, at times, will, if you're doing a seal kit or something, you might as well pop the head off and clean it out.
And I'm not obsessed, but I am thorough.
I like that. You're better off not being obsessed. Awesome. So there's the motors behind that. So any instance where you're going to need to open up and
get into the motor?
Yeah.
Only if we're replacing the transmission housing to replace the oil seal. Other than that, we don't replace the rotors or the windings because it's cost inhibitive.
Is this the oil seal here?
No, that's the race of the bearing.
Okay.
The oil seal is behind that. And actually, I'll go get a transmission housing to show you.
So this is the other side of the housing.
Yeah.
Right?
So this is the back of the transmission housing.
So this is when you're talking about if we have a leak, an oil leak.
Yeah. This is the oil seal right here.
Ah. Okay.
So here's the back side of our bearing, and this is the back side of our oil seal.
That's not easy to get to. Yeah.
The cupped edge is up inside of here. So in order to get, it's not very difficult to get the bearing out, but you have to heat the housing.
Okay.
And then after you heat the housing, you have to press out the seal. Then there's a insertion sleeve for getting the seal back in once you've got it this way. And then when you go to press this bearing back in,
All right,
that's getting it to the right depth.
That's not a DIY thing.
And then when you go and press it back onto the rotor of the motor, or on the motor housing, sometimes this bearing wants to walk its way out. So it's labor.
And you got to take all the plastic assembly and the electronics off the top.
Basically, you're going to break it down to that.
Yeah.
Let me get that.
You have a 9-year-old Kranzle pressure washer.
Correct.
You get milky oil, and you are ready to change your seals.
Okay.
You're going to break it down to this point if you follow my recommendation, because I'm going to want you to use carbon choke cleaner or some form of solvent to get this completely void of any oil sheen, because you want to inspect and without any doubt know that this surface right here is completely smooth. Imperfections in this ceramic coating, see, from here to here is a ceramic coating that's laminated to the surface. And ceramic is used on pressure washer plungers because while it appears to be non-porous, at a microscopic level it does have some porosity to it, and water molecules laying in those pores of the ceramic will cause the seals to hydroplane across the surface, giving you suitable sealing edge when it's, this is making 1,700 strokes a minute to give you your flow and pressure.
And if you have any like a scratch in that, it'll pull little bits of water into your oil housing there. Right,
and what's more common with as the pressure washer ages and the amount of time, with the different hardness and quality of the water, if that porosity is then penetrated by the water and it gets below the surface and it starts to delaminate that ceramic coating, you start to get bubbles more frequently than you get any cracks. This is not likely to crack, which is one of the freeze-proof natures of the pump. Most pressure washer pumps, the brass is not what's going to fail as a result of the initial freeze damage. Most pressure washer, crankshaft style pressure washer pumps in particular, have a threaded shaft that has a ceramic sleeve that goes over it that's held in place with a nut. That ceramic sleeve on average has about a 3/16 wall to it, and it's just brittle enough that freeze causes it to crack very easy. So does thermal shock. You leave the pump in bypass for several minutes and then go and pull the trigger and nice cold water runs across the plungers, it can cause the ceramic sleeves to crack. It will not do that to these the ceramic lamination on these plungers. Majority of that reasoning is because of the nature of the plungers being able to transmit the heat to, from the oil bath to the water housing and vice versa. So this is one of the instrumental parts of a Kranzle pump, and but it's
the preciseness of the stainless plunger combined with the ceramic coating that they're using is much more expensive, much more sophisticated, and much more precise.
And that's why if it starts to delaminate, if you put brand new seals in, that small imperfection will start to groove the seal or harm the seal
Immediately,
and then,
right, real quickly, yeah.
Yeah.
So these are real expensive to replace?
They are pretty expensive, yeah.
Yeah, figures.
This is one more place where you can find cavitation. Like I said, it causes the plungers to go askew.
Mm-hmm.
See that wear right there?
Yeah.
Somebody using this rental wasn't feeding enough water, and I can tell right there that it was askew inside going through the sleeves, right there. And I mean, I've taken apart hundreds of these things, so that, it's understandable that not everybody recognizes these conditions, and I can't claim all that knowledge as being my own. You remember Jeffrey. Jeffrey was a wealth of knowledge. He's one of those guys that remembers everything. But, right there. And it has like a real particular appearance to it. You see how it has that kind of like...
So does that need to be replaced?
No.
It's just...
No, because
that just wear from somebody sucking air through, or not.
Yeah. Well, yeah, not feeding enough water.
Yeah.
Or having, like you said, sucking air. They had the leaking garden hose connection, but the ceramic with its level of hardness, it's what's sealing on both the oil seals and the water seals. So what's happening back here is less important. It's just, where these sleeves start to, if you start to see, you'll usually see it. If this needs to be replaced, that's when I'll replace the seals or replace the plungers. If you can see wear on these sleeves, but the coloration will be different.
This is just like a sleeve in a block with a piston.
Yep. So now I'm not going to replace the oil in here the way that I would do it in the shop, because for the purposes of your video, it'll be more useful for us to do it through the fill. But when you're servicing your machine, I usually will take and then close this, stand it up right, and then put it in
a precise amount.
Yeah.
And
then that way I don't have to wait for it to fill down through the housing, because as you can see from this housing, the oil is entering through, that's the fill tube right here, but there's a cavity up top for, overflow, expansion, that sort of thing, coming down through the ports to get into the main part of the oil housing. It takes time.
So if you're filling, you fill it to this line?
When I lay it down, I usually fill it up to about 1/8 of an inch below this port right here, because when you start to put the and I already have the wobble plate in place.
Yeah. Okay.
Because all these parts take up space too.
Yeah, got it. So we've broken down everything we can break down. When we put the hose back on, we'll show a hose replacement here in a minute. But
well, do you want to go into the electrical part of things?
Yeah, let's do it. We're here. Let's keep tearing it down. So we're going to show the capacitor. You remember capacitor gate? Remember early on when I first started selling these, and we sold like 50 or 60 machines, where the Germans accidentally
Do I remember? Yes, I remember replacing many capacitors. Yeah. Not as many as Mike, but yes, many.
Well, and we convinced a lot of my obsessed people to do it themselves too. So a lot of them just said, "Yeah, just send me the capacitor. I'll pop it. I'll swap it." Oh. What happened was, in the Germans, they were almost darn near in tears on the phone about making a mistake. They don't like to make mistakes.
No, the Germans don't usually admit to mistakes, but they definitely admitted to that one.
Yeah, so where they put a 220 volt, a European capacitor in here, and so they were overamping for the 1152.
Yep. So here we have the enclosure, and of course this is a common replacement item for the 16 and 1322s that get damaged in shipping. This component, this is your enclosure right here, and this is the enclosure lid. And those are always inspect for cracks, because this housing is supposed to be waterproof. And if it's cracked, clearly that's not the case.
If you've cracked this part, it doesn't really matter.
No.
It's the
this
electrical housing.
This section right here is these little channels right here for your accessories are just for the 1122.
Yeah.
But yeah, like you said, these little fins are just aesthetic or superficial and make.
Yeah, but it's part of the fit and finish of the machine that's different from others. The density of the plastic,
But replacing this is not nearly as involved as replacing the whole enclosure.
Yeah.
In order to replace the whole enclosure, you're going to have to disconnect all the wiring, pull everything out, and then rewire it all to get back together. You can do it. It's not impossible, but it is involved.
So there's our capacitor.
So
This is what helps with inrush. Right, so this stores energy for our startup and shutdown.
It's kind of like it stores potential energy.
Yep.
And the one in this model is an 80 microfarad. This funny little marking right here, that's what that means.
Yep.
So our terminal strip here, this is the where the capacitor is wired into the winding, as well as our pressure switch for the total stop feature. You've got your energized wire coming off the power feed, going in, feeding through the pressure switch, and then when it comes back out, it goes to the back side of our on-off switch. So there's the power off our pressure switch.
So this stuff doesn't generally fail, does it? I mean, I don't.
No, well, the on-off switches can fail more often due to neglect or improper. We've had where the equipment is being operated by employees. They like to use the tip of the nozzle to turn the machine on and off instead of bending down to do so. In which case, they break this.
Watertight seal.
Yeah, the watertight
cover.
Cover.
And then it is common for there to be like dielectric grease in there.
Yes.
So don't freak out if that has some grease in there.
Yeah, a little bit of schmutz, if you will.
Really simple. And then right underneath there is the big
Yep.
electric housing.
Right, once you get down below this, there's a couple waterproof gaskets, and then the ground from the power supply is mounted inside, and you can actually see the windings from once you get to that point. Now, in some rare cases where the machines have failed right out of the box, it's been because these capacitor wires get pinched. There's no right or wrong way for them to be routed necessarily, but it is if they get pinched.
So when these are cracked, you've got to take all the wires apart.
We've done that quite a few times too.
Yeah, from shipping. I mean, when you got an 80 plus pound box, it's inevitable some of them are going to get dropped from really high.
Well, according to Wagner, the amount of packing that Kranzle puts in the box was one of the, for these and the 1152s and the 892 is what they call their hand carry unit, was one of the major areas of contention from all of the visitors when he went to Kranzle school.
So you guys, the actual winding, the actual electric motor inside of there is usually just a replacement. You're not taking those apart generally.
No, it becomes cost inhibitive. Yeah. The cost for labor of service and all that.
Yeah.
So, and for units that, you've got a 9-year-old machine, that thing will probably last you another 20 years. Provided that,
Well, shoot, if I pull it apart and clean it up like this, the thing will be like brand new. That's what's so great about these suckers. And you could do things like change the superficial covers and things like that, or change out some of the plastic components if you wanted to,
Yeah, well, my wife's pressure washer started its life as an 1120.
Okay, yeah.
So the precursor to this machine. And then ultimately it became a clone of your 1322.
Yep.
So now, when the wobble plate goes back in, it should not, you shouldn't have to force it. So if you're starting to force it, pull it back off and get it lined up. The swash plate's made of aluminum cast, so it's, you know, it's softer than the steel that the motor shaft is made from. So if you start to force it or tap it on, it's real easy to warp the surface and then get it stuck, and then it's a big to-do.
You're making me, I'm starting to think about all kinds of modifications. I want to put a bigger wobble and get some more flow out of the sucker.
Well, you know, while it is uncommon, it is possible to run a 120 30 amp motor. So you probably have to get yourself a 2 or 3 horsepower though.
Well, what I intend to do is to have them make that for me. I'd take that and make a 20 amp dedicated, one that will get me 2.3, 2.4 GPM out of it. That extra 20% or 10-20% output makes a big difference for washing.
Absolutely.
My 165
in all applications.
Yeah, my 165, because I'm opening up the orifice, I'm running it with a 6.0. So I'm running like 1,000 PSI, but at 3.1-ish gallons a minute. But I'm about to replace that because we can't, I like to show the things that I'm selling. I like to have it.
Right.
And so I'm about to give away or, sell very cheaply my $4,500 165 and put the KWS 700 in there, which I didn't realize till recently actually has a pressure switch. I had no idea because mine runs for 30 seconds. The thing's annoying as crap. Yeah.
Well, it also, that trigger jockey, amp rush, it avoids that. But the highest flow rate I've seen out of a 110 volt high pressure pump system is about 4 1/4.
Yeah. So I need 1,000 PSI. That's what the 950 to 1,000 is my preferred car washing pressure with a 40-degree nozzle, and then as much flow as we can get. Give me as much water as we can.
Can't save the world if you're using all the water, man.
The water's recycled back into the Florida aquifer for me. I can't wait to take mine apart. I don't even use mine anymore, but I still have it. So the 1322, all of this stuff is identical.
And the 16. Nothing's...
The big difference of the 16 is has a much different wobble.
Yeah, just a different wobble, and it looks the same though.
Yeah.
Nothing's...
Slight tolerance difference that...
I can see the difference side by side. You can see the difference side by side, but most common people are not going to notice the difference. So
you're putting the long ones back in to get it to go in evenly?
We're still going to have to...
You have to walk it back in?
Coax it. Now, it's important to note, I use the ratchet to...
Torque it?
Torque it. I don't torque it with the impact gun. Yeah, the torque is not very high. I believe it's 125 inch.
Well, it's aluminum into aluminum. All stainless bolts into aluminum.
Come on, the O-ring is what's sealing everything. You're not necessarily doing a whole lot of favors by over torquing it.
Yeah. So these are brass retaining rings.
Intermediate rings they press up against the oil seal.
No O-ring or anything on those?
No, sir.
Okay.
So those are pressing on the back of the packing assembly, keeping it in place, and likewise doing the same to the oil seals.
Okay. Those would very rarely be a worn item.
Yeah, I have customers that when they replace components insist upon changing them, but it's not necessary.
I guess it could only really be too much DI water that would really leach those.
If you have to go through a great deal of trouble of getting them out of here because of oxidation, like you said, from DI or even some other scenarios with water quality, they clean up real easy.
Yeah. So these are the long bolts that go up top, and the other normal size go in the bottom.
Call them 25 millimeter, I think is the length.
So if you do buy replacement check valves, those will come with a new set of O-rings.
That's correct.
Is this like, are these like tightening a wheel, or you want to kind of work your torque?
Yeah, torque crisscross. And, you know, do a initial torque and then full torque. Yeah, the valve housings on like ARs and crankshaft style pumps, you have 8 bolts. That's the nice thing about the Kranzle pump. I only have to do 4.
Yeah.
So then with our check valves, I usually drop in all 6 O-rings first, just to make sure that none of them are missing. I'm gonna make sure that they're seated down all the way. Now, one thing that's interesting about cavitation, when cavitation takes place as a result of poor water supply or leaking connections, we can usually tell because it'll happen to you'll see it happen mostly on the intake side, O-rings, and also the water seals that are furthest from the inlet. So, because that's where it's having trouble getting the water.
So the reason this is called intake is the water, so the water comes in here and then gets pulled
up
via the plungers. So the check valves make sure that water only goes one way and not backward.
Right.
So why do we need 3 of them?
Well, you need 1 for each plunger.
Okay. But if they're not really attached to the plunger. The plungers are in a triangle over here.
It's all in a function of how the guts, you know, I guess we should have taken a closer look at the back of the housing. This plunger, the top left,
Yeah.
is only pulling water and pushing water past these.
Oh, okay.
The bottom one is doing it with these.
I see. Okay.
And then the right one's doing
Oh, yeah, because of the, okay, that makes sense. I got it. That, hopefully other people will just have to get it too.
Well, we'll have another Kranzle pump pulled apart. And in fact, we're going to look at the cutaway.
Yeah, that makes sense. All right, so then these take green, apparently, green check valves.
Well, green's what's in them. The replacement valves that will, if you get a set of check valves, they'll be the red ones.
They're red, okay.
Yeah. Always do the low pressure check valves first, and tighten them all the way in. If I put these in, put the check valves in, and then put these check valves in, and then tighten down the valve caps, when you do so, it's going to push, air is actually going to push these back up. So you run a chance of unseating the O-ring and something getting off center. Now this I will use the impact for. And in certain cases, especially if we've had issues with water leaking from the check valve caps, occasionally we'll put Loctite or thread lock, and nothing permanent.
Like
you
red,
want,
yeah.
Yeah, you want to avoid the NASA grade Loctite. It's not leaving orbit. But I do like to use the ratchet to run them in so that I know that I'm not pinching the O-ring. And then if the check valve is off center, it can crush the check valve or damage the O-ring or even twist. Sometimes you'll see the check valves where they're misshapen, where it looks like they were almost being twisted.
Plastic, yeah.
Yeah. And we want to avoid that.
So these are like an oil drain bolt where you want to snap it You know, like I noticed you didn't put like even torque, you snap them loose.
Yes.
Because of the softness of the brass.
Yeah. Now here, on these, the trick is to do the outside two first, because the one in the middle that has the pressure gauge tends to get in the way. Like I said, if we were doing a full rebuild on this, I'd take the rings off all the brass. I'd put it all in the parts washer in the basket, let it all get nice and clean, get all the, you know, a little bit of Loctite that's still on there. But me putting it back together like this is the least amount of abuse it's going to see as a rental machine. And then, like I said, he also does a Friday night hangout that's just, you know, hangout for fun that he calls shop nights. So then he has a whole machine shop in his garage. It's pretty neat. His garage isn't as clean as yours, but it has just as many gadgets.
So I could see that you could get in a real rhythm and just crank these things out.
Unfortunately, I'm also, given the amount of time that I've been here, I have many of the part numbers around here memorized.
Yeah.
Just because I'm a numbers guy.
Yeah.
The other mechanic, Mike, he's way more efficient in working on this stuff because he doesn't get distracted, but he does not have any customer service skills. Angela gives me crap about, you know, picking on him like your mother and, you know, does for you and your younger brother kind of thing.
There goes our check valve. Our that's our outlet check valve.
Outlet check valve, yep. And before I put the unloader handle back on, I'll put the cover back on.
I like to watch experts do their thing. Like, for instance, I just bought a ridiculous mountain bike, and part of the prerequisite was I buy it. I'm not asking for a discount or anything, but you gotta like let me come down. Don't unbox it. I want to come down and have him build it. So he's like trying to involve me. I'm no, you do it. I'm just gonna watch. I don't want to do it.
So you're like me. When I was a kid, one of my favorite shows was Mr. Rogers' Neighborhood, when they would do the how it's made type stuff.
Yeah.
I used to love watching that stuff.
Well, and then I'm a visual learner, so I like to watch you do it, and I'll be able to go replicate this. You know?
Yeah.
I don't like to, like, some people are hands-on learners where they need you to like grab their wrist, say no, do this, do that. I don't like to do it that way. So like doing like detailing trainings and stuff, I never like to do because they want you to involve you.
Engage you.
I don't want to do. I just want to watch the master while I've got him there, and then I'll go fumble around on my own. So that pressure switch goes in line on the power. Like, where's it getting power from? It's just in here wired into
It's all
the
inside
switch.
the box.
Got it. Okay.
Yeah, so the terminal strip was where the black coming through the power wire goes into that terminal strip.
Yep, got it.
One side of this goes to the other side of the terminal strip, and then the other side of the pressure switch goes to the on-off switch. Or no, goes to the winding. You'll have one of the leads from the winding that plugs right into it.
So that's how you can theoretically add a pressure switch to a pump that really wasn't designed by swapping a couple. Like you swap the switch and put it in there.
Well, the same switch, you just need a terminal strip with 3 ports, and then you just have to wire it in. Because there's another type of pressure switch You can see it on the machine that's in the showroom up on top of the showcase. It's a pilot assist flow switch. And water from the inlet has to be routed to it as well. So it does more than just start and stop the motor whenever the trigger is open and closed. It will also prevent the motor from running if you don't have water being fed to the machine.
It does more, yeah. There's water sensing.
But unfortunately, flow switches have the magnetic shuttles in them. And even when they're spring loaded, they have a tendency of hanging up, which was one of the Achilles heels, or not Achilles heels, but one of the most expensive service components on the 165, I think. At one point, they were using this one flow switch on there that had a list price of like $400. And it was it was not a popular service item, I'll tell you that. But flow switches can also be adjusted so that they do things in different ways. Like the burners on the hot water machines are actuated by flow switches often, so that you can get flow whether you're using a high pressure nozzle or not.
How the burner versions? What temp did they go up to? Just shy of boiling?
Most hot water pressure washers are set to do an average increase of 120 degrees of heat rise over inlet temperature.
Okay. So if inlet's 60,
180 is the common, yep.
Yeah.
Now, that's the case at full pressure and flow.
Okay.
So with like the Kranzle, with the 2175 that we have over there, one of the reasons why I like having that in the service department is that if we turn down the flow with the unloader valve,
you can get 200 plus degrees out.
I can go up to 300 degrees.
Oh shoot.
In fact, there's a brand of hot water pressure or combination washers. They're hot and wet steam, made in South Dakota, called Sioux, like the Indian Sioux Corporation. Their wet steam, hot wet steam, go up to 320.
Yeah, see, this is a common misconception with these type of pressure washers and like guys in their garage. You're not getting 140 degrees out of your water heater in your house without a burner, without a boiler.
Right.
You can't get those temps, so this thing's good to go.
Right.
You're gonna, whatever you can get, because like I measured mine at my house, I have my water tank set at 140, and I'm getting 120 at the tap.
And you got an electric?
I've got a electric heat pump, yeah.
Okay, yeah. So,
but even like a gas, like an instant on, like a lot of the.
See, I have an oil-fired boiler because I also have baseboard heat.
So.
And I can get if we adjusted the regulation system, because I think there's two sets to it, you could get it up to much hotter. But yeah, like you said, just because I go to my thermostat and set it at,
it's got to travel all the way through the foundation of the house.
And also, my customers think that if I set the thermostat to, like with your AC, if you set the thermostat to 65 degrees, 65 degree air is not what's coming through.
Right.
You know what I mean? It's just setting it, you're actually probably getting less than, a little cooler than that, but it's only going to do that. The thermostat is just it's a limit switch.
Yeah.
Same thing with those burner systems. A lot of our customers think that, the dial thermostats, they think if they set it to 200 degrees that they're getting 200 degrees. And I'm like, did the burner kick off? Because if it didn't kick off while the trigger was being pulled, it's supposed to when you release. Then you never got to 200.
Right. So in most applications, the tap, if you're mixing cold hot or you have a hot water tap and you're in Toronto or whatever, these
because your customers want to use these with warm water.
Yeah, in the winter. Yeah. And these are fine.
And I do that in my house. I use the times that I've done it, I take and just tee off of the tap going to the washing machine in the basement, and I literally just tee it right together and not meter it at all. Just let it mix 100%. So
unloader to be open. How do we say this? So to get maximum pressure, it's actually closed more, correct?
Right, closed all the way. A good way to demonstrate that is with a tank fed system. Because on, and I can point this out on a machine out in front, the machines that have an external unloader valve that are tank fed, we run the bypass line back to the tank. So it's working in the same way that this is. It's getting its incoming water and then cycling back to the incoming water.
Okay.
Okay? If with the proper size nozzle and the unloader valve turned to max, if I'm pulling the trigger and I see water dripping into the tank, then I know one of two things has happened. Either the unloader valve is bypassing flow on this side, or the nozzle size is too small.
Otherwise, in a perfect situation, you would have 100% flow.
Right.
You'd have no water diverted.
Yeah, and
Now,
a good.
as I start to open it, I'm diverting.
So in an external unloader valve
you'd be
setup,
able to see it blowing
you would
back into
actually
the
see
tank.
it coming out. So I've got crabbers that they bypass off the side of the boat, so it's never. So if they release a trigger, they don't have to start and stop their machine because it might be 5 minutes between times that they pull the trigger. And it doesn't make any difference. Like you said, the water's going back to the Florida aquifer. It's going right back in the Chesapeake Bay.
I want to figure out how to do that on a screw compressor, an air compressor, so that I can buy a. Rotary screw compressors don't really work in like consumer environments because they get water in the head if you don't cycle them.
Constant
you have
demand.
to constantly use them. So I have to figure out some sort of purge system to where it runs every day for a certain period of time so I can have one.
Yeah, that was actually where before I started doing this, I used to put in car lifts and air compressor systems and did like pump and tank work for gas stations.
Yeah.
It was all plumbing, which is what gave me a leg up on this stuff.
So now we got to put our gauge back on, and then let's deal with our hose.
Yep. So this is a case where we will use some Loctite.
Loctite so you can get it straight and then leave it.
Yeah.
Nice.
I hate it when I get that stuff on my fingers. You can never get it off.
It's like anti-seize.
Yeah.
I
Yeah,
get
that's
in
the
my hair and my back of my shoulder somehow.
Have you ever heard that that's called the herpes of the mechanics world?
Yeah. Yes, it is. So this is a common thing where, any sort of braided hose, you don't want to run over it or you're going to mess it up.
Right. You crush the braid.
Yeah, then you're toast.
Yeah.
And you start getting water shooting out, little
pinholes.
Yeah, little pinholes shooting out at your face.
And I don't understand why it is that people that are pressure washing don't like getting wet, but.
And you're constantly, you're going to constantly chase leaks. That's part of the game.
Yeah.
I don't care if this thing was $15,000, not $1,500. You're still going to have to.
I've worked on those types of machines too, and yes, they do leak as well.
Yeah, you got water under pressure, so you're going to have to do these things, these things. That's why I'm here. I want to learn how to maintain them, and then provide people with a resource where they can come to maintain their machine as well. I think doing this stuff is kind of fun. It would get monotonous in your case where you're doing it over and over and over again. But
yeah,
if you're a garage guy, this gives you a nice, fun little weekend project to get in and clean up your beloved, fancy German engineered machine.
Yeah.
So to replace the hose, we don't need to remove the reel.
Nope.
We don't even need to remove the reel if we were going to do a seal kit.
Yes. Or any other internal, pump head or
Right.
oil housing maintenance.
I guess you could try to leave it on there, but it'd be a pain in the butt to.
Yeah, I want to be able to get in there and see stuff.
Yeah.
Like you, like.
So we have a 15-meter hose, just like 49 feet and change. So we actually have just gotten a kit to adapt the 3/8-inch hose to this. And that would actually go in here. So if somebody wanted to do some sort of aftermarket longer hose or different hose, that's what we would do. We'd be removing this tube and then adapting, I believe, to that location.
Well, actually, I'm not completely certain of which kit you're describing, but
I'm not sure which
Patricia and I have the components where you can actually take remove this section, remove this fitting, you plug it, and then you change out this outlet fitting, and that's how you switch to the 3/8.
That's what I have. That's the kit that I have. Yeah.
So
we're gonna kind of
because basically what that does, the precursor to the 1122 was the 1120, and it came in the plain 1120 and the 1120T.
Yeah.
This is technically a T series, and we don't carry it in the standard series. So, but the other nice thing about Kranzle is they do use a lot of uniform parts across many models and machines, and we just supplement those parts to accomplish that goal.
So is there any way to do an aftermarket hose on this thing, or is it a proprietary type fitting on the inside of this?
The fitting on the inside is proprietary. However, if I'm not mistaken, they do have an adapter fitting to adapt from this to 22 millimeter.
Yeah.
But the tricky part would be within the space inside the drum.
You're gonna have to be sticking out.
Well, that, or you'd probably have to come out and then do a 22 millimeter to 90, going to
3/8 of some sort.
Yeah, 3/8.
We need to figure out how to do that.
So you would be adapting and then readapting. But since you are very persistent and Kranzle seems to respond to persistence, we may accomplish that after all. And I'm happy to help with that.
Yeah, I'd like to figure that out because this is a nice hose, but my Cobra Jet hose is nicer. I'd like to be able to put a 50-foot Cobra Jet on this thing, on the hose reel.
Semperjet.
Yeah.
Kranzle Semperjet.
And it's a $275 Kranzle Semperjet.
So
I have some guys that blow through these hoses, it seems like every other month.
With the 1120T, and also the 2020T and several other series of Ts, the only method of replacing the hose was to remove the drum from the chassis, take the brackets off, unscrew one side of the drum so that you could get to the side of the swivel that's inside the drum. However,
this one,
and I guess you have to use your other handy dandy camera. So where the hose exits from the drum, you have this fancy little door, which opens up pretty readily. You may not even need a flat screwdriver, but it does help. We won't force it, we'll pop it very gently from both sides. And now we have the hose fitting. Now, what is unique about this hose setup, or this swivel setup, I should say, is that this hose reel technically has no swivel. The hose itself is swiveling inside the brass fitting. So as we can see on this brand new hose,
interesting.
And that's why that was one of the areas where they really did a great job of coming up with a different design. This part of the hose is swiveling inside the fitting, which is why it has that longer stem, and that's why it's not, that's the proprietary connection that makes it difficult to...
Right. Nobody makes anything like that.
So,
and that makes it less leak prone.
Right. So if now we did have at one point in time, I think it might have been some of your customers that had some complaints where they were having difficulty winding up the hose. Like the hose reel was getting bound up. And I went through a bunch of headaches trying to figure out where in the pillow blocks on either side of the reel what was causing it to bind up. But it wasn't in fact that was binding up.
It was gummed up, or
I think on the one that I took apart, it was either a white oxidation or a rust buildup between the surface of this nipple and the brass fitting inside. So the solution was to break loose the collar. I had to work the fitting out carefully because I had to use a pair of channel locks on the collar of the hose to get it to break loose from where it seized to the brass. Once I got it out, I cleaned up this portion of the hose end and also the inside of the fitting that's inside the drum, and then coated it real well with some grease, and that was the resolution. So
The hard water, the lime buildup on that.
Right. So barring any kind of misalignment of the mounts for the hose reel itself, if you're having trouble winding up the hose, it is the actual connection that goes inside the hose drum that is the major issue. Now the $100,000 question for servicing this component or replacing your hose is the size of the
It's a 25.
25. And of course, nobody has a 25.
Yeah.
So if you must, you can use a 1-inch, but I recommend trying to use the right size. But whatever you do, don't use a adjustable because you won't get it tight enough inside there and you'll end up stripping it.
No tape in there.
No tape. Or on your 22 millimeter connections.
Yep.
So, and this is another place where snug is all we really want. You gotta do a little ballet of the hose drum and the wrench to get a full rotation. And once you think it's loose enough to remove by hand, you're still gonna have to loosen it up a lot more.
Yeah, I mean, you can see it's too deep, a lot of threads.
But like I said, I can neither confirm nor deny that there's an adapter fitting for this particular fitting. The big question is how much space are you gonna have to get it to come out the size? And you're not using, you said a 3/8 hose, not a 1/4 inch?
Nobody makes a decent quarter besides Kranzle.
So how much 3/8 could you possibly fit on here though?
I don't know, we have to find out.
Got to get it on the drum before you can get it on the reel, right?
Well, I mean, I just have never taken one apart. I'd think we could get 50 feet on there, I don't know.
I think that's optimistic.
Yeah, it probably is.
This is a fairly simple replacement process too.
Yeah, that's true, because we got a 1/4. Every company that I've approached, like nobody makes a good 1/4 inch hose. No aftermarket. It's always this. I don't like this.
You want the smooth jacket?
Generally, yeah.
Like you said, just like taking this thing apart, why don't those guys want to do a fun little project and get the black lines off the concrete? So what kind of royalties am I looking at, Matt?
You get to have a
free t-shirt at least?
Yeah, talk to Angela about that. She's the one paying you.
Well, she's paying me for this part.
Yeah.
Once it goes on the internet, I can't get a free t-shirt, man?
Sure, you can have one. I'll send you a Kranzle t-shirt. Next time they send you one, I'll send you
Yeah.
See, look, I think we could fit a 50-footer on there. I'm going to try it.
Only if your customers wind it up like I just did.
Yeah, well, all of them will. All right, so back to what we originally started. Oil.
Oil.
This is the most in-depth oil change in the history of oil changes. So, what oil are we supposed to use? People get real nervous about this.
Yeah.
So what I intend to do is I'm going to get me some cases of Kranzle oil so we can put the original stuff in, which they're probably buying from Castrol or some other place like that. But we're going to get some real fancy Kranzle oil thingers. We got to figure out how much this stuff costs.
The Kranzle oil, I believe, is 15W40 gear oil. And you can tell when you open up the container, it smells like gear oil.
It's pretty. So we'll probably get my hands on some of this for those of us who like to stick with the plan. But the rest of us.
So for those that aren't able to get their hands on the fancy schmancy Kranzle gear oil, 5W50 synthetic is a suitable alternative. The Mobile One, Castrol Syntec, it's available on a number of other brands as well. But
Ames oil, yeah.
So this is relatively common, easier to find.
So now how the heck do we know how much to put in there? That's the hardest part.
We read the manual.
Okay.
So the manual says that it takes 0.3 liters.
Okay.
But we're not going to measure. We're just going to use the dipstick. We're also
But how do you use the dipstick when the dipstick's so darn hard to get in and out? This is what I was trying to figure out. Maybe mine old one.
I only have trouble getting it out the first time.
You see, mine didn't spin like that. And maybe that's why everybody thought I was such an idiot. Maybe I just had my threads are tight or something, but I can get the right there. That's it. And then I've got to get channel locks.
Yeah.
So I bought a new dipstick, brand new, whatever the $20 dipstick or whatever this thing costs, and I mangled that one. So now I have a mangled.
I remember that. I remember helping Patricia ship you all those.
Yeah, and so I got one, and I think I may just have, I don't know, maybe they had tighter threads back in the day or something.
Could be. They could have.
So I can't check the darn oil because I've got to use like I had to torque the crap out of it.
I would personally, if you're not gonna, if you want to measure it out, measure it out. You know, I don't keep a measuring cup handy in the service department.
Yeah.
But
well, that's the point of the dipstick. I just couldn't use the dipstick.
Right.
Because I couldn't get it back out.
But we've also had other pressure washer pumps that we service that don't have a dipstick. So in those cases, we will improvise with, you know, usually a zip tie works real well because the grooves on the zip tie help to, you know, keep oil in there.
Just cut it the same length as that or something.
Yep. Or just, you know, hold it at the same point and lower it down in and check that way.
Got it. So 0.3 liters. So you're gonna eyeball it, stick it in, eyeball it, see, and get it to where it gets to. Is if you overfill it, is this just like any other engine where you could damage things?
Well, in this particular case, in the pump, it's not likely to cause any damage. It's more likely to cause a mess.
Yeah.
Because of course,
it'll seep out the hole at the top.
Yeah,
as
expands.
it heats and expands.
Right.
Yeah.
And, you know, but there is a fair amount of error.
Room for error.
Yeah, room for error. Since you're okay, you've got probably, I don't know, maybe 10 to 25% of space remaining. That's, you know, in relation to the volume that it's actually intended to hold.
And what really helps me understand now, seeing what it looks like, seeing where the oil's going. I thought the oil was filling this whole darn thing up.
Yeah.
And I had no idea, you know, so it's that little compartment.
Right, well, and, you know, and when you're looking at it as a transmission housing, you know, transmissions are using oil in a hydraulic manner where it's, you know, the fluid level is very important in those applications. This is just a bath lubrication system.
Yeah. So clarification, 0.25.
0.25. I usually use this for gasoline. You know, one of the funniest stories I remember hearing about you was apparently in a video your wife turned a couple bottles around in your garage to see how long it would take you to realize that they weren't properly aligned.
All my friends do that to me too, like my non-obsessed friends.
Yeah.
They like to come over to my house and sneak in my closet and move my t-shirts around and stuff. Yeah. They think it's so funny. All right, so 0.25.
Yeah. So a liter is 1,000 milliliters, correct? Right. So we need 250. Yes. So we've got a beaker that measures 140. So we'll have to do 2 pours, but
we're just cracking open a $60 bottle of juice.
And you can smell it. It's definitely a gear oil.
Yeah.
And as we all learned in science class, make sure the bottom of the meniscus is to the line.
Yeah, I like this better than having to try to get that dipstick to work.
And the nice thing is that, you know, with the manuals being online, if you can't find your owner's manual, you can refer to there for the.
I never read it and always punt it immediately.
Well, I see, and that's what differs between us and the Germans. They keep it in the bathroom and use it for, you know, reading.
Well, if they liked it so much, maybe they should have someone write it in English instead of trying to translate it.
Apparently, they don't know how to use Google Translate.
Yeah.
The great thing that they did when they evolved the oil housings on these smaller pumps, they didn't used to have this cavity up top. It used to just be a tube, like this tube right here, the drain tube, that went directly into that housing. So if you filled it too fast,
it would shoot right out.
It wouldn't all. It didn't. You had to be careful how quickly you poured it in.
So that should be it. I mean, have you ever seen the wheels? The wheels don't fail. The handles don't fail.
Unless it gets dropped real hard.
Yeah,
I can show you how to take the wheels off. It's pretty.
You just pop the cap off and The power cord shouldn't need any servicing.
Yeah, once again, as long as you don't, you know,
try to tow your car with it or something.
Well, what happens most often is the GFI will go bad from
dropping it.
Yeah, from impact or from getting yanked out of the receptacle. The spades on there will fail. But as we did when we went into the to take a look at the capacitors, when you remove the cover, open up the waterproof enclosure, you'll take and disconnect the connections from the switch. The hardest part is you'll also have to take out the screws from the base part of this enclosure, because the box where the ground is mounted to the aluminum of the motor housing, that's where you got to get to get to the screw. So once you remove that, the only, beyond that, the tricky part is feeding the terminals through the cabinet connectors. So once you can, if you can feed it through, it's pretty easy to do. So while the manual did say 0.25, maybe that was just for the 1622.
Seems a little light.
Yeah, it's a little light. I think it is going to take that extra half, 5/10.
Could have 0.3.
That would be 0.5. I put 0.25.
Oh, yeah, yep.
Now, if you're eyeballing it, looking down the fill tube, as we could see in this housing, where this surface is, I want to see oil filled up in there. Can you see
where it squares off there?
Yeah.
Yeah, filled up to that.
Yeah, up to that point.
Yeah.
So, you can see it in there too.
Give me that light again. Yeah, camera's not. Oh yeah, I see it. I like that. That's where it's at. So you're filling right up to where it flattens out.
Right. So yeah, if you look, it's easy to tell from this housing. This is the inner cavity of the transmission housing.
And you're going to fill up to this.
Right, into that.
Because you can see it. You can see the top side of that.
Yep.
Yeah, I like that. No freaking dipstick. I hate dipsticks.
Does your Porsche have a dipstick?
No. I hate that more. I hate not having a dipstick. Because that's the stupid electronic thing that doesn't work for squat. I always get overfill readings. I'm like, no, I know it's not overfilled because I filled it, a half a quart short.
Hate dipsticks, but hate not having a dipstick.
Yeah.
Oh, it's a cruel world, man.
I like this where I can just look in there and I know exactly where to fill it to.
Yep. So we took it all apart.
So that's 1122 deep dive. Doesn't get any deeper diving than that. There's not really anything else to do. Now we know how to fix these things. So
well, at least you know how to take them apart and put them back together.
So what I think I'll probably do is at home. So I'll probably release this whole series. Like this will be a multi-part series. I mean, we shot 4 hours of video, all good stuff. And so I'll probably release this as a Kranzle 1122, 1322 deep dive. Everything about the 1322 is it's virtually identical. So servicing will be the same. So now we know how to service every part in piece. I'm going to reference every individual part in piece. So I'll be placing an order for that before I leave to have that in the store. And then what I'll probably do is do a service on my own and do like short, here's how you do a seal kit. Here's how you change the oil. Here's how you repair an unloader, that kind of thing. Just do and fumble through it as a DIYer. So thanks for sharing that. That was awesome.
Yeah, no problem.
We're going to dig into some of the bigger machines probably tomorrow. But let's just show them, in wrapping up this video, let's show them the cutaway to show us how some of these things work. And then we'll wrap this one up. All right, so here's just to kind of wrap up all we were just talking about, this is a cutaway of the unloader and how this works.
So now this is an external unloader valve from an older style Kranzle model, but the premise is still the same. You have the output on the pump feeding the unloader valve. This check valve right here is the bypass check valve. And then here is the outlet check valve. And then this is your control piston. And then below the unloader valve is the bypass port. So
if this gets open, so this goes this way, which makes this gap here bigger. No.
So, well, let's start with the primary purpose. When you release the trigger on the gun at full pressure, it's pushing this check valve closed.
Okay.
Then pressure is building up through this port back here behind the head of the piston, which then pushes the piston forward and pushes the ball bearing out of the way. So the fluid that's coming in to exit the pump then is going down this channel as opposed to going through the outlet.
Okay.
Okay. Whenever you want full pressure, the tension on the spring, you have to have full tension on the spring, or else pressure is still built, pressure can still go through this port even when this valve is not closed. So the less tension that's on the spring, the pressure that's in the system, in the line, can build up behind the head of the control piston and push forward to push the ball bearing open to allow a percentage of flow
to bypass. So when you're bypassing, it just goes back through the system or goes back down to the plunger? Or?
So if from this side of the pump, you can just barely see it, but down there,
yeah,
I'm shining the light down through the bypass port, and it's actually reflecting inside where this would be the water inlet.
Right.
So where the water inlet, where the water goes into the low pressure or the intake side of the pump, that's also where
So because there's more pressure here than coming in, it'll just use less water and just refeed it. So you're reusing your pressurized.
You're decreasing the demand on the feed.
But does that build up more heat to the head of the pump, or?
Well, it's not so much it builds up more heat as less water leaving the pump is carrying less heat away from the pump.
Yeah. And then here's our triplex and our wobble. So the wobble turns, driving the pistons, which creates pressure in the head of the pump, which then all that magic happens we were just talking about.
And then you can also see over here, this is your intake valve, and your low pressure and high pressure, or intake and discharge. So as water comes this way, the plunger retracting, pulls water past this check valve, and then when after it fills the cavity and it pushes forward, it pushes water past the high pressure or discharge check valve, and all that water, all the outbound side of those check valves all are connected to this channel, which is then the outbound channel.
And then you have cooling through water and then cooling through a fan on the backside.
Yeah. Now the fan is more integral
to the electric motor.
Yeah, to the motor itself.
And then heat sinks, of course, all around.
Right.
Surround.
We see screen printers and kennels are the ones that have the most trouble with motor failure on Kranzle pumps, because the cover on the back. No, often they get the Quadro, and the Quadro doesn't have this whole back end completely open. Neither does this. The 1122. You've got
there's a little vents, but yeah.
So what happens is the kennels, you get all the dog hair pulling in, and starving or snuffing out fresh air going in.
It's like your hair dryer getting all gummed up with crap. Yeah.
And then same thing with screen printers, but then it's the emulsion that gets on the back of there, and they'll end up overheating the motors. They pop a lot of breakers, they blow a lot of capacitors.
All right, so that's a deep dive into Kranzle pressure wash, specifically the 1122, 1322, but the concept is the same, just with different wobbles, different size head, different size electric motor.
Yeah, between the wobbles and the diameters of the the plunger diameter. So as you go up in flow rate and pressure, you're going to increase the you know, the plunger diameter, as well as you can also increase the wobble angle to get more flow as well.
Got it. Thanks, brother. Thanks for watching. More, I'll have more Kranzle stuff. I'm going to go and try to replicate all this stuff on my own to see if it's possible. I'm sure it is. Thanks for watching. As always, stay tuned for more crazy.